Hello there, welcome to this video. This is 3-3 and today we are going to talk about implicit differentiation, an important type of differentiation where our x's and our y's are mixed together and we can only, the relationship between x and y is implied. That's why they call it implicit differentiation. So, up until now, we have only worked with functions written in explicit form, meaning that y is expressed as a function of x. Now, however, some functions are difficult or impossible to write in explicit form. Instead, they are in implicit form, meaning that x and y are written together in an expression without solving for a single variable. Now, we'll go ahead and give you an example of explicit form. Here is y, it's equal to 2x squared minus sine x plus 4. I know what y is in terms of x. Implicit form, here's a different equation, and notice that I have x's and y's mixed together. The relationship between x and y is only implied. So, we're going to go ahead and talk about how we can take a derivative of these. And a key question we have, what does it mean to find a derivative? Well, this question is often misunderstood because we have only been working with explicitly written functions. If given an equation involving y, asking to find the derivative is equivalent to finding or solving for dy dx. And again, that's Leibniz notation, and Newtonian would be y prime. Now, Leibniz notation is very, very important because they're telling you what you're differentiating with respect to. I'm differentiating with respect to x, and the derivative of just x, the slope of x, is just 1. So that's very, very important. Reminder, the derivative of y is dy dx, and writing that, again, means the derivative of y with respect to x. Taking the derivative of an expression involving y requires the same rules that we use for expressions with x, and especially derivatives with chain rule. And I'll give you an example here. Let's say I have something very, very straightforward. 2x squared to the power of 2. Well, if I was going to go ahead and take the derivative of this, dy dx, and especially if I did a sub, I want to show this with a sub, right? Here's chain rule. I'm going to go ahead and use power rule, 2u, but I'm differentiating with respect to x, so I have to multiply now times the derivative of u times u prime. Okay, and we're going to be doing the same thing today as we go ahead and differentiate implicitly. All right, so example number 1. What is the derivative of x cubed? I'm taking the derivative with respect to x. Well, that is 3x squared. That's it. Okay, b. What is the derivative of y cubed? Well, it's the same thing, 3y squared, but I'm differentiating with respect to x, so I have to multiply times the derivative of y with respect to x. And you'll also see this written as 3y squared y prime. So multiplying times the derivative of y. C, the derivative of x plus 3y. Well, that's the derivative of 1, right? dx, differentiating with respect to x. The derivative of x is 1, plus the derivative of 3y with respect to x is 3, multiplied now times the derivative of y, which I'll call y prime. Or you could call it dy dx. Okay, and you'll see every time you're taking a derivative of y with respect to x, you're just going to multiply on times the chain, or the derivative of y. D, the derivative of x y squared. Oh, here's essentially having two functions. I have x, that's one function, and I have y squared, that is another function. So I have to go ahead and use product rule here. This one requires product rule. So what I'm going to do is I'll utilize the product rule. I have the derivative of the first, which is just 1, times the second, which is y squared, plus the derivative of the second, which is 2y, times the derivative of y with respect to x, so I can call this y prime, or dy dx, times the first, which is x. So that's just product rule, okay? And that's a glimpse into implicit differentiation, right? We just took the derivative there with respect to x. So implicit for differentiation, we're going to want to end up solving for dy dx, or y prime. So here are our guidelines in order for implicit differentiation. Step number 1, you're going to differentiate both sides with respect to x. So anytime you're taking a derivative of y, treat it as you would normally treat x, but you're going to have to multiply times the derivative of dy dx. Then what you're going to do, you're going to collect all the terms involving dy dx on the left side of the equation. Shift all the dy dx's to the left, move everything else to the right. Step number 3, factor out the dy dx. You're going to pull dy dx, and then you're going to solve for dy dx by dividing by the rest of it, okay? So let's go ahead and look at an example. And they have the guidelines here again for us. There they are. Okay, so they say find dy dx given that y squared plus 2xy minus x cubed is equal to 4. So okay, I'm just going to go ahead. I'm going to step 1, differentiate both sides. So step number 1. All right, well the derivative of y squared is 2y, and I'm taking the derivative of y, so I have to multiply times y prime. Actually, I'll do it in dy dx first. Dy dx. Okay. Plus, all right. Here I have a multiplier 2, so I'm going to take out the 2, and then I have two functions, x and a y. So I have to use product rule. Again, they're multiplying. Okay. So the derivative of the first, x, is just 1 times y plus the derivative of y, which is 1 y prime, times the first, which is x. Okay. So we can distribute that 2 in a moment. And then the derivative of negative x cubed is negative 3x squared. Pen's not liking me right now. 3x squared is equal to, the derivative of 4 is 0. Okay, let me clean this up really quickly. We have, oh, actually I forgot to put that in terms of dy dx. Dy dx, and that was a 1. Okay, so this is 2y dy dx plus 2y plus 2 dy dx. Oh, there's an x there too, huh? 2x dy dx minus 3x squared equals 0. Okay, so I want everything with a dy dx or a y prime to stay on the left side. So notice those terms have a dy dx. Everything else, get moved over to the other side. So it looks like I'm going to ship my 2y to the other side. I'm going to move the 3x squared over to the other side. So we have 3x squared minus 2y. Okay, so these cancel. And we get 2y dy dx plus 2x dy dx is equal to 3x squared minus 2y. Okay, and then now I'm going to go ahead and I am going to factor out. So that was step 2, right? I moved everything over to the other side. Now step 3, I'm going to take out my dy dx, and we get dy dx times 2y plus 2x is equal to 3x squared minus 2y. Okay, and then step 4, I'm going to go ahead and divide, and I'll put it up here. I don't know why that box is there. I guess so you don't have to turn the paper. So now I'm going to divide. So dy dx is equal to 3x squared minus 2y divided by 2y plus 2x. And there is our derivative. We found dy dx. That's the derivative of y. Okay. One thing that we will see going forward is notice I have x's and y's in my derivative. So if they ever ask you what is the slope at a certain point and they give you an x and a y value, you'll have to plug in x and y into the derivative to find that slope. Okay. All right. Example number 3. We're going to do the same thing, except this time instead of writing dy dx, I'm going to go ahead and I'm going to utilize Newtonian notation with a y prime. Example 3, find dy dx given x cubed minus xy plus y cubed. All right, step number 1. I'm going to go ahead and I'm going to take a derivative of each side. The first term, 3x squared, okay, minus xy. They love to do this. Implicit differentiation loves to multiply x and y. This is product rule. Be very, very comfortable with the product rule here in this setup. X times y. So I have the derivative of the first, which is 1, times the second, which is y, plus the derivative of the second. Okay, so the derivative of y is 1, and then times the derivative of y, which is y prime, with respect to x. Okay, times the first, x. Okay, done. Plus y cubed. So that's going to be 3y squared times the derivative of y with respect to x times y prime is equal to 0. Okay, so let me clean this up. 3x squared minus y minus x y prime plus 3y squared y prime equals 0. Okay, identify what terms have your dy dx or your y prime. So there they are. Okay, so all of those terms stay put or get moved to the left if they're on the right. And then now we're going to go ahead and ship everything else to the right side. So I'll move the 3x squared, I'll add y, and it looks like that's all there is, minus 3x squared plus y. Okay, so these cancel. And we get negative x y prime plus 3y squared y prime is equal to negative 3x squared plus y. Okay, now I'm going to go ahead and I'm going to factor out. I'm going to pull out, right? That was step 2. Step 3, I'm going to pull out all the y primes. So y prime times negative x plus 3y squared is equal to negative 3x squared plus y. And what I'm going to do now is I'm going to divide both sides by negative x plus 3y squared in order to isolate my y prime. Okay, so we get y prime is equal to negative 3x squared plus y divided by negative x plus 3y squared. Okay, and there is the dy dx. There's your dy dx. And on an AP exam, if they say find dy dx, I would write my final answer in dy dx. I would give them exactly what they asked for. Hey, this is dy dx. I would utilize that notation. Okay, example number 4. Write an equation of the line tangent to the graph of x squared minus y cubed equals 0 through the point 1, 1. All right, they want an equation of a line. So again, I need two things. One, I need a point, which they were kind enough to give us. Sometimes they're not so kind. Sometimes they'll only give you an x value, and then you have to go ahead and find y. But they give us the point, and then step 2, I need a slope. So how do I find a slope? Well, you're going to have to take a derivative. Okay, so my function, x squared minus y cubed equals 0, the derivative of that is 2x minus 3y squared times y prime, which is equal to 0. So I'll go ahead and I'll solve for y prime. I'm going to move the 2x over to the other side. Okay, and so we get negative 3y squared y prime is equal to negative 2x. And now I want to isolate my y prime. Well, I'm just going to go ahead and I'm going to divide by the rest of the term that contains it. I don't have multiple terms with dy dx, so I don't have to factor anything out. That step's kind of skipped in this location. So I have y prime is equal to negative 2x divided by negative 3y squared. Okay, so that's my general slope, but I want it at a specific point. I want it at 1, 1. So there's an x and there's a y. So y prime evaluated at 1, 1 is going to be equal to, I'm just going to get rid of these two negatives, right? Two negatives make a positive. So 2 times 1 divided by 3 times 1 squared, which just gives us 2/3. So there's our slope. Our slope is 2/3. That's m. M is equal to 2/3. Okay, so the equation of a line. Y minus y1, which happens to be 1, is equal to m, 2/3, times x minus 1. Okay, and there is your equation of a line. Make sure I got it. Got it. Okay. All right. Example number 5. This is a common FRQ question on AP exams. If you get an implicit differentiation question, which is possible. This is 2022. Last year there was not one, so coming up for this year, it's possible. So here they say, given the curve, and it's an implicitly defined curve, show that dy dx is equal to that. So what we have to do is go ahead and show that. So I'm going to take my equation that they gave us, and I'm going to go ahead and differentiate. Now this one looks like a lot of fun. Lots of heavy lifting. I have product term in the first term. Looks like I have, or product rule, sorry, in the first term. I have product rule in the second term, and then I have that negative floating in front of the second term. So this is going to be a fun one. Okay, so I'm going to start by differentiating. Derivative of the first, which is 1, times the second, y squared, plus derivative of the second, 2y times y prime, times the first, which is x. All right, there's my first term right there. Okay, minus, now I'm going to go ahead and put brackets because I have to distribute that negative. Derivative of the first, 3x squared times the second, y, plus derivative of the second, well that's just 1 times y prime, 1 times y prime, times the first term, x cubed, okay, is equal to the derivative of 6, which is 0. So let me go ahead, clean this up. We get y squared plus 2xy y prime minus 3x squared y plus x cubed y prime is equal to 0. So everything that has a y prime gets to stay. Here they are. They get to stay. Everything else has to go to the other side. So we have 2xy y prime plus x cubed y prime is equal to, and then when I move these over, the 3x squared y becomes positive and the y squared is negative, right? I'm just subtracting. Switch the signs. Okay, do that to the other side. And then now I want to go ahead and factor out the y prime. So take y prime out. We get 2xy plus x cubed is equal to 3x squared y minus y squared. And I'm going to divide. So now I'll divide down here by this term. So 2xy plus x cubed. 2xy plus x cubed. Okay. And if everything goes well, dy dx is equal to 3x squared y minus y squared over 2xy plus, minus x cubed. Did I not distribute? Man, I fell for it. Man, even the bell's mad at me. So we get a negative here. This is negative, which makes this negative. See, I told you that negative is important. Come on. Okay. Minus x cubed. Ta-da! There, I showed it. So when they say show it, they're giving you the answer, but you need to show all of these steps. Okay, almost there. Here we go. Part B. Part B. All right, so we are asked to find all points on the curve whose x-coordinate is 1 and write an equation for the tangent line at each of these points. So if I'm going to go ahead and again, I'm going to write an equation, I need points. So the points that we need, they tell us, hey, x is 1. I don't have the y value, so I'm going to have to use my equation that they gave us in order to find y. So this is all example 5. This is part B, so we use the same stem. X squared, y squared. I'll write this here. X squared, y squared. Sorry, not x squared. It's just xy squared. Minus x cubed. Y is equal to 6. And what I'm going to do is I'm going to plug in 1. And when I do this, we get y squared minus y is equal to 6. Okay? And I'm going to use this now to solve for y. So I will move the 6 over to the other side. Y squared minus y minus 6 is equal to 0. And then we'll factor and solve. Y minus 3, y plus 2. And we get y is equal to positive 3, y is equal to negative 2. Okay, so I have two y values where my x coordinate is 1. So my point is 1, 3, and my other point is 1, negative 2. Okay, well now I need the slope for each of these points. How do I find the slope? Well, you're going to find the derivative. In this case, we already found it. And in part A, right, they tell us 3x squared y minus y squared. Okay, so let me go ahead and do this. I'll do this separately. I'll put this point over here. We'll put 1, negative 2. Okay, so dy dx, or y prime, is equal to, so 3x squared, so 3 times 1 squared, times y, in this case it's 3, minus y squared, that's 3 squared, divided by 2 times x times y, that's 3, minus x cubed, that's 1 cubed. Okay, and let's see, in our numerator we have 9 minus 9, 0, divided by 2 times 3, that's 6, minus 1 is 5, 0 over 5. So our y prime here is 0. That's a horizontal tangent line. Okay, so the equation is going to be y is equal to, y minus 3 is equal to 0 times x minus 1, and that just ends up being the equation y is equal to 3. So there is one of our equations. Okay, and then I need to do the same thing now, but for my other point. Again, so y prime is equal to 3 times x times y, x squared times y, which is negative 2, minus y squared, divided by, and again, I'm getting this from, right, our given information up here. Okay, divided by 2 times x times y, which is negative 2, minus negative 2 cubed. Okay, and this turns out to be negative 6 minus 4, that's 2. Where is it? We have negative 6. We do it in stages. Negative 6 minus 4. Negative 10, that looks better. Okay, over negative 4 minus, is that negative 8? Okay, so that's a plus 8, so we get 4. Oh no, this is x cubed right here. So x goes there. That's 1, okay, which is 1. So negative 4 minus 1, which would give us negative 5. Okay, so negative 10 over negative 5 is 2, and our slope is 2. So then the equation of the line, y plus 2 is equal to 2 times x minus 1. And there is our equation. All right. Whew. Implicit differentiation. A very, very important topic. A very, very difficult topic. It can be very cumbersome. We're going to spend lots of time on this in class, and I recommend lots and lots of practice. It's very uncomfortable at first, but once you get used to it and taking the derivative of y being y prime, you'll feel a lot more comfortable with it. Give me a thumbs up if you like this video. Subscribe for more awesome math videos. Catch you in the next one. Bye.